Swayam Prabha. Digital India. Educated India.
So, welcome to this 10th session of Ergonomics for Beginners Industrial Design Perspective. Now, today is a module 7 human physical dimension concern. Under that today's session is a 10th class, that is statics and dynamic anthropometry standing. Now, last session brief, if I consider, just to recall whatever we have discussed last class, we have stressed upon the facts that the basic structure and shape of the human body are identical among the human race all over the world, but size and proportion patterns in all body parts differ with different origin. So, we need to have human body dimension measurements for a particular group of people when we are going to design something for their use. Some information based on some other population may not be suitable to use for another population group. Like in this slide, we can say that different proportions, the cultural differences and the requirements, basically though it is same, but race, age and other climate wise some different treatment is necessary. Now, when we see the last classes growth pattern, human beings have assorted body sizes and rates of growth that follow certain patterns, but physical development from birth to adulthood does not show the same proportional growth of all parts of the body that we need to consider when we attempt to make a design to fit human body, that is for that particular user or that particular user's group. We need to understand how our body behaves, and accordingly, if design is made, it will be well accepted. Now, design behaves means a human body behaves means the structure, movement pattern and etc. Like we can say that ectomorph, lean and thin body structure, mesomorph, mostly the muscular body structure, endomorph is a fatty body structure. These figure types we also need to understand to attempt design for a specific group of people where this type of figure types are represented in which proportion or which percentage wise. Now, from this slide we can say that though all look like same, but their requirement and dress pad design whatever they are wearing is not the same. They have the special likingness. Now, we cannot change our assorted body size. Instead, we need to design something that fits to our body. Now, with this we can say that current session we are going to discuss certain body external landmarks for specific measurement. Like in this session we are going to cover the body anatomy and anthropometry specifications, anthropometry, that is static anthropometry, dynamic anthropometry and anthropometric data applications, need for Indian anthropometric data sources and static anthropometry standing landmarks specifically we are going to discuss in this present session. Now, body anatomy and anthropometry. In this, the medical emphasis of our body dimension is that bone, muscles and other minute detailed dimensions of the anatomy are mostly referred to for medical and other necessities. But for design emphasis it would be, even while designing products for human use, the external body dimensions are of most importance, and the anthropometry has to be considered. While designing individual items or products, one has to take into consideration the dimensions of the product or items, their layout pattern in a given space, the ease of reach, their use, etc., to match with the anthropometry of the users. Means human body dimension must match with the design dimensions. For that we need to know the human body, that is the body measurement, that is anthropometry, height, breadth, length, circumferences, etc. Anthropometry is the subject which deals with measurements of the human external body dimensions, that body parts, their strength, speed and their range of motion. This is the anthropometry. At present, we would be restricting our discussion only to the physical dimensions of human body parts and their relevant reach values only. We are not going to discuss the strength and body speed and range of the motion of the body parts in this module. External human body dimensional measurements taken when a man is placed in a rigid and static position, perhaps in any posture, that is, if a person is standing, that is standing erect with arms put down, hanging vertically from the shoulder, legs are straight, balance equally distributed through the legs, chest up, look front. At this position, whatever the body dimensions measurement, or sitting posture, means in a posture sitting where all the knee, waist at the 90-degree angle, the trunk and head straight upright, and the arm is also hanging from the shoulder vertically down with the elbow at 90-degree angle, where and the forearm spread forward. In that posture or any other adopted postures for a specific task purpose, and at that position, when we are measuring heights, lengths, breadths, depths and circumferences are termed as static anthropometry. Means static anthropometry means when body is in a rigid or static position in any either any specific posture or any adopted posture, the body measurements at that position are the static anthropometry. Now, dynamic anthropometry is required more than the static measurements in the field of design, because when we do some task, then we adopt some different body postures and we change this also. Now, if we take that arm length, so arm length is from this length, arm length, but I without changing my body I can extend my arm, means this position is extendable. So, now at this moment if I want to touch something I can extend my arm. So, this measurement is now is a dynamic measurement, though this was the static measurement. So, this movement allowances we have. So, the human body is not rigid, but rather always dynamic. Even in sleep it has movement. The dimensional measurements of the human body with various movements taken into consideration in different adopted postures which the work context demands are termed as dynamic anthropometry, means movement taken into consideration. These two figures are saying that what are the different body movements are normally taken care of. Now, the anthropometric applications in design. The static anthropometry is to have the basic dimensional concept generation. Means static dynamometry is to basic dimensional concept generation of a design, and the dynamic anthropometric considerations are to accommodate the movement and activity. Now, with this the anthropometric landmarks are the external points of the body structure with their muscles and skinny cover on it, and these should be taken into consideration. Means for these points, height points and some prominent bony points are normally taken as landmarks. So, this we are going to discuss now in a standing posture. Now, why we need Indian anthropometric data considerations? The age, sex, race, geographical locations or geographical regions, even different occupations, all influences human body dimension. In earlier class also we have discussed this matter. Now, accurate dimensions of clothing and personal equipment used by persons, as for example, headgear, footwear, the spectacles sizes. Life saving and support equipment would be of great value because human functional dimensions and the range of movements possible demand that appropriate allowances should be made while specific designs are developed. Appropriate allowance value to be added, like if we take a door height, then to cross a person through that door, his body height is enough if we consider, but we are not sure whether that person will wear a headwear or will carry something on his head. So, that clearance is necessary. Even we do not know whether that person will be a short height person, average height person or a tall height person. In that case, the appropriate allowance value addition is necessary. It is advocated by experts that the anthropometric data to be used for specific design considerations of specific users groups should be based on same population groups. Yes, data from another group may not fit to a other group. The use of non-Indian anthropometric data in Indian designs and other imported ready-made designs often result in mismatches with the requirements of Indian users. Now, some ready-made garments are available. When we buy it, suppose the trousers, when our waist matches, the leg length does not match, and these are quite often experienced. Accidents and serious mistakes may occur if any design dimensions do not exactly match the body dimension of specific groups. Now, Indian behavior is also not similar to that of foreigners. The way we use our body, we squat on the floor, we sit on floor or any other platform on a squatting or a cross-legged position. We adopt many combination of postures, that is sit, stand, squat, leaning and etc., and sitting on chair and desk positions also, leaning, bending. So, Indian behaviors in all respect may not be similar to others. Some Indians prefer sitting on the floor and performing a range of activities there. Non-Indian data sources do not provide the references for these Indian specific requirements. So, in this module, we are going to discuss the specific measuring techniques, so that if any designer, ergonomist or someone wishes to conceive a design idea for Indians use, if those specific dimensions, Indian dimensions are not available, then how those data can be generated, those principles, those techniques and use principle we will discuss in this module. Now we are going to discuss some landmarks points. Now, Indian being a multicultural nation with an ethnic diverse population, we need to consider when we are going to design something like a walking stick, suppose that walking stick should match with different population groups within India, or whether we should make a design for a specific group, that we need to consider this. It would be of direct relevance to strengthen design practice in India with data on human dimensions collected from Indian population groups for the specific needs of Indian users. Now, the static anthropometry standing position landmarks. Now, the static anthropometry standing is that body measurements include direct measurements of various body parts, say heights, lengths, depths, breadths and the circumferences of head, neck, trunk, hands and legs in some standard positions. When these dimensions are taken in standing static posture, it is called standing static anthropometry. Now, the specific landmarks in a standing posture is that now the rest of the slides we are going to describe some landmarks where some figures have been shown here. In figures some numbers are there. These are the reference numbers where these definitions are given. Definitions are very brief. Now, here one is that weight, the body weight of the person with minimum clothing and without shoe. But while using this data, we need to consider allowances that he may wear a heavy jacket. So, when this weight we consider as per standard measurement system, minimum clothes and without shoe, but while the person in working condition, he may have a heavy shoe also. So, these allowances we need to consider. Now, the heights. The measurements in standing posture heights from floor. If this is the floor, and then what are the heights? Vertical distances from the floor to the respective points as mentioned specifically, we are going to discuss now, of the body while standing in stretched erect posture except relaxed normal standing height, feet together and firmly placed on the ground, weight equally distributed on both feet, looking straight ahead, palm flat against side of the thigh. In this condition, the normal standing would be from this floor when a person is standing normally without stretched erect. Normally when the person is standing in normal relaxed erect posture, this is the normal standing height. Normally heights are measured in millimeters. The stature is that suppose this number 3, these are the some reference numbers and these are the parameters. This parameter is this, suppose this stature is a parameter, height is a parameter, this 3 is the reference, 4 is the reference. Now, in this figure, this 3, this is the stature, means top of the head standing in erect stretched posture from the floor, as it is mentioned that height from floor. Eye height, inner corner of the eye. So, now when we see that eye height, if a person is standing erect, when we measure this inner corner of the eye height is high, this is taken as a normal eye height measure, because when we look with the normal eye position, that is the center of the eye vision. It becomes a center of the eye vision. So, this is the eye height conditions. Now, number 5 is a cervical height. Cervical height is that if we see from this head end, here a groove is there. From this groove, if we come down like pressing like this, one most prominent bone structure is here. So, this is the 7th cervical bone. Most prominent spinous process of the 7th cervical vertebra, this point and this height is the cervical height. Mid shoulder. Mid shoulder is that uppermost point on the mid level of the shoulder, like here. In this case, the middle of the shoulder and that height is that, means the number 6 is the mid shoulder height. Acromion, where arm ends, where this collar ends, this position is the acromion point. So, that height, acromion point is for that movement purpose. Most lateral point of the shoulder on the superior surface of the acromion process of the scapula. The scapula bone, this triangular bone, this point is matching here. So, this is the 7th is the acromion point here. This is the acromion height. Suprasternum. If we see here, this notch area is the suprasternum group. Uppermost point of the sternum is the upper sternum height. Substernum, if we see like this way, the where this sternum ends, this group, this height is the substernum height. Lowermost point of the sternum is that substernum height. These are the some standard landmarks are mostly used in anthropometrics, and these are necessary for various design dimensions fixation. Now, number 10 is that elbow height. Elbow height, when you put your arm down, this elbow, this point, the most proximal point of olecranon tip is the olecranon tip of the ulna bone. This is elbow height. 10. Number 11 is that abdominal extension height, maximum extended point of the abdomen, wherever it comes, maximum protruded point. The waist is that here, upper margin of the lateral iliac crest, like this here, this is like this. So, upper margin of the iliac crest, where the belt is worn. So, this is that waist point. The crotch is that for male and female, where the lowermost point of the trunk between the legs, that wearing underwear position, our body is like this way. So, this position is crotch height. Then buttock extension height, where the maximum extension of the buttock point, this is the buttock extension height, it is maximum extended point of the buttock, the fleshy protuberances from forming the lower and back part of the trunk. This is the buttock extension point. Now, the gluteal furrow point, where this there is a furrow point here. So, this point is at gluteal furrow point. The furrow formed in between the buttocks and the upper thigh muscles. This is the buttock, the gluteal furrow point. Number 16 is that the tip of radius, the tip of the radius, the stylion bone. This is tip is 16, is this one. The trochanter, uppermost point of the lateral projection of the greater trochanter bone. Earlier we said that some of the body anthropometric landmarks depend on the different tips of skeleton structure. Here the trochanter bone, if we see this bone is like this way. So, this is the trochanter bone over here. Uppermost point of the lateral trochanter bone, here the bone structure is like this way, this point. Uppermost point on the lateral projection of the great trochanter bone. Now, knuckle like this, these are the knuckles. So, when we hang down our palm, the most prominent the point of the knuckle, tip of the knuckle of the middle finger, where the middle finger meets the palm at dorsal surface, where the middle finger meets with the dorsal surface, here this point, like here, meets here, this is the point, like this, that height. So, this is the point. So, this is the point. Now, dactylian, the tip of the middle finger, this is the dactylian point, 90. Now, mid patella, in this patella, this is a small free bone is here, this is mid portion is that patella. Midpoint of the patella, the knee bone, this is the height. So, it describes where you can bend your legs. You can bend your legs like this. So, this from this point. Now, medial malleolus. Medial malleolus and lateral malleolus. If we see this leg, this position from the front side, if we see, it is like that way. So, these two bony projections are there. So, inner part is medial malleolus and outer side is lateral malleolus. So, outer side this portion, this height, lowermost point of the fibula is the lateral malleolus and inner side is that lowermost point of the tibia is medial malleolus. Now, after this basic body heights in standing erect posture, some breadth, depth and length. Breadth is this breadth, depth is that from front and back breadth and some other lengths. Like span and span akimbo. Span is that when you are extending your full arm, this is the span, and when both arms are folded at this elbow point like this, then this is the This is span akimbo point. So, breadth, depth and length are that horizontal distances between two respective points. Now, first span is that maximum horizontal distance between the middle finger tips when both the arms are stretched out fully sideways perpendicular to the trunk, and span akimbo is that maximum horizontal distance between the tips of the elbows when both the upper arms are stretched out outside sideways perpendicular to the trunk and the elbows are fully flexed so that the tips of the middle finger of both the hands touch each other. Like this, maximum body depth, breadth relaxed. When you are standing in a relaxed position, this is the maximum body depth, body breadth. The chest depth from sidewise, this is the chest depth. Then maximum body depth, whatever the posture, stand erect or relaxed from front and the back. If we make a plate, then the maximum distance between these two plates, this is that maximum body depth. Then acromion to olecranon tip, this is from acromion point, this point to olecranon tip, this olecranon tip to this length, and olecranon to stylion length, olecranon to stylion length, like that way, and etc. So, if we read this point, then maximum body breadth relaxed, chest depth, maximum body depth relaxed, acromion to olecranon tip length is that length between the most lateral point on the superior surface of the acromion process of the scapula, this is scapula, and the most proximal point of the olecranon, that is the tip of the ulna of the at elbow. Olecranon to stylion length is that is 29th, this one. Length between the proximal point of the olecranon, that is the tip of the stylion length. Now, circumferences. There are different body circumferences, anywhere we can take it, but here we are giving some representative landmarks. Circumferences are horizontal, otherwise mentioned specifically circumferences at different areas. Like 30 the chest mid-tidal on bust. Bust is a two nipple point, and a mid-tidal means when we are taking breath in full, at that time the total circumferences. This is the chest mid-tidal on bust, on the chest at nipple level. Then 31st, the below nipple level, on the chest below the nipple level, means we can say that roughly at a substernum level. The 32 point, this 32 is at abdominal extension waist point, at the waist where the maximum abdomen point is there, on the abdomen at its maximum extended point at waist. 33 is at waist level, on the waist at the level of the upper margin of the lateral iliac crest where the belt is worn. And 34 hip at gluteal extension. Gluteal extension means where the maximum mass of the buttock. At the level at the maximum protrusion, gluteal extension of the buttocks. Now, we said that different time and others also changes this dimension. Just for one example of that waist measurement, if we go to a tailor to give our body measurements for making a trouser, then if we give the waist measurement circumference after full stomach food, then whatever the measurement they take, accordingly if the trouser is made, when we wear that trouser, when the stomach is empty, then that trouser will be loose fitting. But at the same time, if it is a reverse, in a hungry stomach, if we go and give measure of this this trouser circumferences, that at waist, then after a full stomach food, it will appear as little tight. So, these are the some cases we need to consider, and designer has to use his own tactics when and how to use these measurements. So, when these measurements are taken, the subject's condition has to be recorded properly. So, while using, one can use it with all these considerations. Like some other landmarks, that upper thigh and etc., upper thigh, middle thigh, lower thigh and knee circumferences, like that calf and etc., all circumferences are measured. Like, and then relaxed elbow, when elbow is relaxed, these circumferences, like on the elbow encompassing the elbow pit, and the olecranon tip of the arm is hanging relaxed position at that time circumference, and at relaxed forearm, maximum horizontal circumferences at the lower arm hanging relaxed whenever found. So, like that wherever, and 42 is that wrist circumferences, and like that with different circumferences are taken, and that we will talk later. Now, lead to next classes. With this, what we understand? Practicing designers and others use ready references and thereby arrive at varied human dimensions in design context. Sometimes some data might need to be generated for some specific design applications, and for that the methodology of the general survey and statistical compilation may be of relevance to ergonomic practitioners, researchers and students. The following session would help in understanding the procedure and becoming acquainted with the statistical implications of anthropometric data as used in design in general, that we are going to discuss. Now, the next session we are going to discuss on the sitting postures, body, landmarks that are used for different ergonomics activities, and rest there will be other 3 classes where we are going to discuss in the class. Now, coming session will be class number 11, anthropometry landmarks, sitting postures, followed by class number 12, static and dynamic anthropometry, squatting and cross-legged postures, class number 13, the measuring techniques of all these body dimensions, like in standing, sitting and different squatting and cross-legged postures and others relevant. And class number 14 of under this module will use statistical treatment of data and percentile calculations for design application. So, the next lead to next class is that we are going to discuss this seating anthropometry. So, till then I think we have to think how we can use human body dimensions in day to day life experiences. We must observe furniture and other design items we use everyday life and compare with our body whether it matches, what are the problems we are facing out of this mismatch. If it does not match, then how it can be modified, or if we want to develop some specific design for that, what type of body dimensions we must consider for that. Let us have a look into our own life, because whatever design are being designed, that is for our use, for our benefit. So, we must feel comfort, our body dimension should get acquainted or be compatible with the designed items what we are going to use. So, we will meet next day, coming day we are going to meet it. So, thank you very much for this day. Thank you.